Hey guys, this is Rahul here from Edureka. Welcome to this session. Alright, today we have an agenda to talk about K-means clustering. Now, what is K-means clustering and what is clustering actually? So let's try to understand that first in detail. But before that, this is what we are going to learn. Introduction to machine learning, cluster analysis, type of clusterings, introduction to K-means clustering, how K-means clustering work, and finally, I'll take one example where we'll talk about credit card company. We'll take one data set and we'll try to solve that problem. All right. So now what is, first of all, machine learning? So machine learning is a type of artificial intelligence that provides computer with the ability to learn without being explicitly programmed. If I take an example, let's say I want to do prediction for house price. Let's say I'm in Gurgaon and I want to know what is the house price of my house. So how will I judge that price? I will judge that price by maybe area of my house, distance from the city, number of rooms in my house, maybe locality. So these are some of the features. Based on that, I want to do, or I will help that features to do the prediction. So here what I'm doing, I'm actually predicting the continuous variable, which is house price, like 20 lakhs, 30 lakhs, 40 lakhs, 90 lakhs. So like this is a continuous number. So when I want to do a continuous number prediction, that it is a regression. Regression is one type of supervised machine learning. Now, why it is supervised? Because we have this data as a labeled data. I already know the house price of my house. Now I will check what my model is saying. Let's say my house price is 25 lakhs, but my model is saying 10 lakhs. Then there is a huge error. That means my model is not predicting correct output. Let's say I have my house price as 25 lakhs again, and my model is predicting 24 lakhs 50,000, which is very near to my actual house price. That means my model is predicting far better and good and giving me good accuracy. So that is one of the scenario of machine learning, which is a supervised learning where I have the labeled data, and then I want to know, okay, this is a house price which is predicting a continuous variable. That is my supervised regression. Regression is my one of the supervised learning. Another example of regression is like predicting salary, predicting number of YouTube likes in my video. Then I can say predicting maybe revenue over the period of time, or maybe revenue of my stores. So these are some of the examples where I apply regression, which is a supervised machine learning. Then there is one more supervised learning, which is known as classification. I want to classify. So when I want to predict a discrete variable, yes or no, whether you guys will like the session or not, yes or no. So what are the options we have? Yes and no, two options. So that is discrete. So when I want to do prediction with discrete as output, that is classification. Whether my employee will leave me or not, yes or no. Whether my patient will get disease or not, yes or no. Whether my customer will leave me or not, yes or no. So these are like classification algorithm. Again, this is a supervised learning because this is again a labeled data. Because I have a set of data which consists of previous customers, and I know that which customer converted, which customer did not convert. So I already have the data set accordingly, and I will use that data set to train the model. And then when I will get the new data, I can actually do the prediction with that model. So supervised learning is nothing but where I can check my accuracy, whether the accuracy is correct or not, whether my model is working fine or not. That is my supervised learning. So in supervised learning, we have two scenarios, regression and classification. When I want to predict the continuous number, that is regression. When I want to do prediction of discrete number, yes or no, that is classification. After that, unsupervised learning. And that is what we are going to talk about here. K means clustering. I want to cluster my customers. I will consider you guys as my customers. Now, I want to know what type of customers I have based on spending score and maybe income. Let's say I have a customer with low spending score and low income. That is one cluster. High spending score, high income, second cluster. High spending, low income, third cluster. and low spending score, high income, fourth cluster. So these are like 4 clusters from my data, which is very much possible. Some of the example like credit card company. If you see credit card company, right? In credit card company, we have platinum customers, gold customers, silver customers, bronze customers. How they decide? They decide based on their spending score. They decide based on their maybe income. If people are using more of his credit card, more of their credit card, then it's a maybe platinum customer because the spending is more. So that is how clustering works. I want to classify my students. I want to cluster my students. These are poor students, these are excellent students, these are average students, and so on. How will I do that? Clustering. Now clustering is unsupervised. Why? The reason is it is unlabeled data. I don't know whether, let's say, Srinivas is my excellent student or poor student. I don't know. But using the model, I can decide whether he is excellent student or not based on number of answers he's giving in the class, marks he's getting in the exam, or maybe participation in various activities. So based on that, I will decide, okay, Srinivas is an excellent student because he is getting good marks and so on. But I cannot check that whether it is correct or not. That is why it is unlabeled, and that is why it is known as unsupervised. I don't have something to prove. It is purely based on the data set. So that is unsupervised way of learning. Machine learning use cases. Google self-driving car. Google self-driving car is a smart driverless car. It collects data from environment through sensors, takes decisions like when to speed up, when to speed down, when to overtake, and when to turn right. So basically here what happens is Google, what it actually do, what this car actually do, it captures the images. Suppose the car is driving, it captures the images which is in front of that car, then it reads the image. So obviously machine cannot read an image directly. We have to convert it to numbers. So machine, what it do, it will convert the picture into number based on the pixels. We have these RGB codes, right? So based on that RGB code, it convert to matrices. You must have heard about TensorFlow. Tensors. What are tensors? Tensors are collection of matrices. So if I have an image, if I convert that to matrices, it will create a collection of matrices, and then that will be read by a machine, and it understands whether something is there in front of the car or not. Based on that, it will stop or it will proceed. That is one of the example. This is but a more advanced AI example. Next is, as we discussed, supervised learning. Let's read through this. You will have more idea, but I already gave the idea what is supervised learning, right? So supervised learning feed the classifier when training the data set and predefined labels. As I mentioned, right? Whether Vijay is one of my student here in the class, whether he will convert or not, whether he will join Edureka class or not, for example. I want to predict that. So I will use the old data set, like let's say Srinivas. Srinivas and Vijay has same features, same age, same salary, same education. So Srinivas was my student. So the chances of Vijay to become my student is more. So I'm using the old data, which is Srinivas, create a model, and then using that model, I will predict for Vijay. So that is what my classification example. It will learn to categorize particular data under a specific level. If you see here, when and where should I buy a house, right? So again, as I mentioned this example, house features, area crime rate, bedrooms, distance from headquarters, area square feet, and locality. Based on that, I want to predict my house price. If more crime rate, obviously my house price will be very less. So these are some of the features which will help me to predict the house price. So these are like independent variables. And what is my dependent variable? My house price. We guys did our schooling and we already know some mathematics there. Y equal to mx plus c. That is my regression equation. Y is what? Is my dependent variable, which is house price, is equal to mx plus c, where x is my independent variable, m is my slope of a line, and c is the intercept. If I have multiple x's, let's say house price, I want to predict based on number of rooms, area of my house, distance from the city, crime rate. So I have 4 x's. So equation will become y equal to m1x1 plus m2x2 plus m3x3 plus m4x4 plus c. That is my regression equation. What is unsupervised learning? As we discussed, I want to cluster my data set. An image of fruits is first fed into the system. The system identifies different fruits using features like color, size, and its categories, and then categorize them. When a new fruit is shown, it analyzes its features and put into the category having similar feature. as I mentioned, right, my students, based on number of marks, based on number of answers they give in the class, participation in various events, I want to cluster my customer. So here also the same thing is happening. So unsupervised learning is like, based on the feature, I will cluster the students, cluster the customers, cluster the employees, which employee is doing good, right? So I want to cluster my products, maybe which products are doing good. So this is like very, very useful way of clustering the data so that I will have more insights from that and I take good decisions. Let's take one more example. Let's say I have launched a new course of data science with Python part 2. It's a latest course with all the new technologies and all the new algorithms. Now I want to launch this course and my marketing budget is very less. I have 10,000 customers around me. I have 10,000 contacts of my customers, and my budget to market is only 1,000 customer. I can market only 1,000 customers. In that 10,000 customer, I have customers from, let's say, medical. I have customers from BCom, from engineering, IT professionals, and various other fields. Now, if I take a random 1,000 customer, there are chances that I may market medical customer or maybe BCom customers. Now, what are their chances to convert? Nil, right? Because they have different line. They don't understand what is Python is. So I want to cluster my customers based on, let's say, their education, based on their age. Let's say I have customer with different ages. Some customer are from 20 to 25, 25 to 30, and 60 to 65. If I target my course to 60 to 65 years of age of my customers, the chances are less that they will purchase the course. But if I target the young generation, they will purchase because they want to switch their job, they want to learn new technologies, and they can use that in their new companies. So here what I am doing, I am based on the features trying to get the particular type of customer where the chances of purchasing Python course is more, and then I will market them. So obviously I'm narrowing down the customer base, hitting the exact customer base, and then targeting them for marketing. So here I'm saving the marketing cost because my budget is for 1,000 customers. I had 10,000 customers. I clustered to narrow down the customer base, and then I hit the exact point of customer which I think will purchase the product. That is IT professional and engineering folks who are from IT background or IT engineering with the age of 20 to 25 years of age. So chances has increased. I can say it's a good marketing campaign because I have hit actually the exact type of customers. So that is one more scenario, right? So here I am saving a lot of cost because let's say if I target 10,000, 1,000 customer of medical, obviously the chances of conversion will be almost 0%. I lost that money for marketing. But if I use clustering and target my exact customers, in that case, I'm saving my money because the chances are 80% maybe because they will get course or they will purchase the course. So it's a beautiful marketing campaign because I hit the exact amount of customers. Now cluster analysis. Let's talk about clustering now in detail. So clustering means grouping of objects based on the information found in the data describing the object or their relationship. The goal is that objects in one group should be similar to each other but different from objects in another group. That is what I mentioned, right? It deals with finding a structure in a collection of unlabeled data. These are some of the techniques. K-means clustering, which is highly used. If you know the tool like Tableau, it's a reporting tool. It also has a feature to do cluster the data, and that also runs K-means at the backend. So K-means is highly used. Then we have C-means clustering or fuzzy clustering. Then we have hierarchical clustering as well. So these are the three methods which we use for clustering. But as I mentioned, K-means clustering is in demand because it will help me to understand how many clusters we should have in the data set. Clustering use cases. So again, let's read this, right? So we have marketing, discovering distinct group of customer databases, such as customer who make a lot of long distance calls. So basically segregating the customer, right? Suppose I come up with a new product where it will help my customer who are doing the long distance calls because of the cheaper rate. So I will target those customers. So I have to cluster that. Insurance, identifying groups of crop insurance policy holders with a high average claim rate. Farmer crash crops when it is profitable, right? So like insurance also we can classify the customers. Land use, identification of areas of similar land use in the GIS database. Seismic studies identifying probable areas for oil gas exploration based on seismic data. So there are like various use cases where we can apply k-means clustering and cluster the data and then use that data for future prediction or maybe future actions. Types of clustering, as we discussed, k-means, it's an exclusive cluster. We create clusters, it will be like separate altogether. I have cluster 0, cluster 1, cluster 2. It's like altogether a separate cluster. There is no overlap between the customers. So an item belongs exclusively to one cluster, not several. K-means does this sort of exclusive clustering. Then we have overlapping clustering as well, which is like C and fuzzy cluster. There are chances that there will be overlap of my customers or anything in two clusters. You see these blue dots. These are like customers which are in both the clusters. So an item can belong to multiple clusters. Its degree of association with each cluster is known. Fuzzy C means does this sort of exclusive clustering. Then hierarchical clustering, when two clusters have a parent-child relationship or a tree-like structure, then it is a hierarchical clustering. So basically, in hierarchical clustering, we create a dendrogram. So there is a concept of dendrogram which create a tree-like structure, and I can have a main cluster, then multiple subcluster, and so on. So that is why it is known as a tree-like structure and hierarchical clustering. Now let's talk about k-means clustering, how it actually works. So k-means clustering is one of the simplest algorithm which uses unsupervised learning method to solve known clustering issues. Divides entire dataset into k clusters. K-means clustering require following two input, number of clusters and the training set. So basically I require a dataset and how many cluster you want. You can see I have this total population and then I have group 1, group 2, group 3, group 4. It actually divide that into the clusters. These are some of the examples. Various news URL related to Trump and Modi are grouped under one section. Right? It's like maybe it's a presidential or prime minister's speech. I want to make that in one cluster. Maybe cricketer speech will be in another cluster, something like that, right? So that is one of the examples. K-means clustering automatically clusters news stories about the same topic into predefined clusters. To plot a students in an area as given below. You can see I have a school. I need to find specific location to build school in this area so that student doesn't have to travel much, which is a very good problem again. This is the data set. Based on the area, I want to cluster my students and then decide where I can have my school, because in the cluster, let's say in one cluster, I have more students because those students are living in that particular area, like majority is in one area. So I may try to create a school near to that area so that the intake in the school will be more number of students will participate in the school. So that is again a good example for clustering. So as I mentioned, there are a lot of examples where I can apply k-means clustering. Now what I want is, let's go and try to solve one problem, right? But before that, let's try to understand the algorithm. First of all, I need to know how many clusters I should have. As I mentioned, k-means clustering will help me to decide how many clusters I should have. Now how to do that? There is a concept of elbow method. You can see this elbow method. Now the WCSS, this is also known as WSS or WCSS within cluster sum of squares, or WSSS within sum of squares, is defined as the sum of square distance between each member of the cluster and its centroid. For example, let me go to the next slide. Here, let's say this X, you see here, this X is my centroid. Now I want to know like which of the point are near to this centroid and which of the point are near to this centroid. That is what the end motive is, so that I can create a cluster. So what my algorithm will do in k-means clustering, to find the number of cluster, it will first create a single cluster. Once that is done, it will create a single centroid. It will find the distance of that centroid with all the points, and then it will give me one number. Obviously, that will be Euclidean distance. So Euclidean distance is what? Which is nothing but hypotenuse. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is my Euclidean distance. So it will create one centroid and find the distance with all the points and then give me the output. That will be one number. Then what will happen? It will create two centroids. It will find the distance again of each centroid with each cluster points. It will sum up again. I will get one number. Then 3, then 4, then 5, and so on. So you can see here, these are like number of clusters. With one cluster, obviously I have one centroid. I will have a huge distance because it is finding the distance of that centroid with all the points. So I'll get a huge number here. Then with two clusters, I have two centroids. I will find the distance of individual centroid with the points in that individual cluster. It will be reducing. So you can see there is a sudden drop out here at certain point in time, which is at cluster number 3. The values are almost same. There is not much sudden drop out there. And this is known as the ideal number of clusters. You see like an elbow point. It's like an elbow joint. And this is my ideal number of clusters. And that is how I'm able to find the ideal number of cluster, which is through elbow method. Then what I have to do? Once I know that the ideal number of clusters are 3, I will pass 3 as a cluster in the algorithm and it will generate 3 clusters for me. As of now it's showing 2, so it will generate 2 clusters like this. These are the points, these are the centroids which are, and these are the points which are near to that centroid. This orange you see, this is like a near to this centroid, and blue ones are near to this centroid. And that is how it will do the clustering. Once that is done, obviously my centroid will change because the first centroid was created by the machine randomly. After that, what will happen? My centroid will change because it will go to the place where maximum density is there. So you see orange coming towards orange points, blue is coming towards blue point. Again, it will find the distance for all the points. And there are chances that my points will shift from one cluster to another cluster. So you see that there is a shift in the points from one cluster to another cluster, and this is my final number of clusters. Because after that, my centroid will change again. Again, there are chances my point will shift from one cluster to another cluster. This process will go on, and it will run till the time when it will stop moving one point from one cluster to another cluster. And that is my final number of clusters. And that is how the K-means clustering works. Now what we'll do, we'll take one example. We'll try to solve that and we'll see how it actually works. This is the data set which we have. I have to cluster my customers based on annual income and spending score. As I mentioned at the start of the class, that annual income, spending score, let's say more annual income, more spending score, less annual income, less spending score. So now I want to find the clusters based on these two features. And again, this is like unlabeled data. So now let's apply this algorithm, which is K-means clustering on this data set. So let me go to Python Jupyter notebook. First of all, I have select my working directory. The small customers is present at this location. So what I will do, I'll change my working directory and select this as my working directory. So I'll go here. I will have a package called os, import os.chdr. Chdr is what? Chdr is change directory. So I'm changing my directory. So before I change the directory, I will show you what is my current directory. So let me first do all this double slashes, and after that I will run import os.get.cwd. My current working directory is what? The same. So basically I have the same working directory, so I don't have to do this change dir because this is the working directory where my file is present. So to get which is my working directory, this is the command. To change This is the command. I don't have to run this command now because my working directory is this one where my file is present. So I don't have to change that. So let's go here. And first of all, I will import some of the packages. The packages like pandas, numpy, and matplotlib. Pandas is a package which will help me to import the data from external sources like Excel, CSV files, and so on. NumPy is a package which do all the mathematical calculations and create arrays and matrices. And matplotlib is a package which helps me to create the visualizations, create the charts, right? So these are the three packages I will require so that I can import the data set, do some manipulation in the data, and then finally create the visualization. So let's do that. Import pandas as PD. I'm giving alias as PD. Import numpy as np. Import matplotlib.pyplot as plt. I'm giving the alias because in some scenario my package names will be very big and I don't want to give the package name again and again. We do this aliases in SQL as well. We make a big table, give alias and use that alias again and again. Same I'm doing here as well. After that, I have to import the data set. So data set, which is a data frame I'm creating, pd.read. My file is a CSV file, mall customers.csv. I have the data set and you see data imported successfully in my data set, in my Python instance. If you want to check whether all the data is imported or not, we have this length command which will help me to find the total number of records. We have 200. Let's go to the CSV file and check how many records I have. It is 200. So the data is imported successfully. Things are good. Now what I want to select annual income and spending score because I want to cluster my customers based on annual income and spending score. So I will slice these two columns and create a new array, and I will use that array to create the cluster. And how to do that? Let's do that. So we have X I'm creating because X is what? My independent variable. I'm taking this as an independent variable. Based on that, I want to create the clusters. So X is equal to dataset.iloc is a function which will, using index location, it will slice the data. Colon 3:5 dot values. I have X, which is nothing but salary and spending score. After that, what I want? After that, I want to create elbow chart because I want to know how many clusters I should have. So from sklearn, which is a very powerful machine learning package, you have the website for sklearn as well. If you have any doubts, you can go to this website and get all the relevant details about this package. You can see the power of this package. I can do classification, I can do regression, I can do clustering, which we are doing now. I can do dimensionality reduction, model selection and pre-processing. A lot of things can be achieved, which is a machine learning in Python. Scikit-learn, very powerful. From sklearn dot cluster, import k-means cluster because we are talking about k-means clustering as of now. WCSS within cluster sum of squares for I in range 1,11. So basically I am creating 10 clusters as of now to check where I am getting the elbow joint. If in the 10 clusters I will not get the elbow joint, then I have to increase my number of clusters because I want that elbow joint. But let's say I am going with 10 clusters for now and we'll see whether we are getting an elbow joint or not. So k-means is equal to k-means, I'm calling the package this function k-means, n clusters. I want to iterate on I, where I will change from 1, 2, 3, 4 till 10, comma init is equal to k means plus plus. Now what is this init is equal to k means plus plus? It will initialize what? The centroids. So basically this init equal to k means plus plus will generate a centroid, which is random centroid, and this will be generated at the point where the points density are more. It's not like randomly it will just generate anywhere. It will generate the centroids where the densities are more, so that my iteration will reduce because I don't want multiple iteration to generate a cluster. It will take, because it will take much time, it will take much resources. That is why init equal to k-means plus plus will help me to generate a centroid which will be at the most density populated section. Once that is done, I have k-means dot fit, and I want to fit what? I want to fit x, which is salary and spending score. Once that is done, we have WCSS dot append. What is WCSS? Is an empty list. Append k-means dot inertia. So this will help me to find the Euclidean distance which we discussed. One centroid, find the Euclidean distance from all, give me the sum of value. Two centroid, Euclidean distance of two centroids and the points in that cluster, sum up, will get the value. Then three centroids, then four centroids, and so on till I is equal to 11. That means 10, because range function will give me number from 1 to 10. 11 will not be participating. So it will create 10 clusters. I will get this inertia. And if I check my WCSS, you see I'm getting some set of numbers. Now this is what? This is the Euclidean distance. With one cluster, this is the Euclidean distance. With two cluster, this is the Euclidean distance. With three cluster, this. With 10 cluster, this. So basically the Euclidean distance is reducing. But with this number, I will not able to find it properly. I have to create a chart. So what I will do, I will create a chart, plt.plot range 1, 11, comma WCSS. Here you go. You get a beautiful elbow chart, and from here I can clearly say that my elbow joint is at cluster number 5. After that, there is very less in the reduction in the Euclidean distance. So from here, I will able to understand that 5 is the ideal number of cluster which I should have, and I can create 5 number of clusters in my data set. How can we do that? We just have to k-means bracket n clusters. This time I will pass 5 because I know 5 numbers of cluster are the best in this data. Init is equal to k-means plus plus, and finally I will do the prediction of k-means dot fit predict x. Now what happened? Why k-means? If I will check, you can see that I am getting the cluster number for each customers. It is starting from 0 because indexation in Python starts with 0. So 0 is my cluster number 1, 4 is my cluster number 5. So I can clearly see that customer number 1 belongs to cluster number 2 because 1 is 2. Customer number 2 belongs to cluster number 4, and so on. So from here I got the detail about which customer belongs to which cluster. But how will I see that? I have the data set here. I know this is my customer number 1, customer ID 1, male, 19 years of age. So he belongs to cluster number 2. But it is very difficult for me to look at numbers and then look at this. I want it in a single table so that I will have the cluster number in front of this. One more column as a cluster number. What I will do? I will do the concatenation, index join. So pd dot concat bracket data set comma pd dot data frame k-means, then square bracket close, then x is equal to 1 bracket close. If I will execute, you can see that now I have a holistic view which shows me the customer details, at the same time cluster number as well. And I can see from here the salary is less, spending score is less, belongs to cluster number 2. You can see customer number 3 also, his salary is less, her salary is less, and the spending score is also less. She belongs to cluster number 2 as well. So from here I can clearly see that how customers are segregated based on salary and spending score. You see my salary is less but spending score is high, cluster number So that is how you can put that in a single table. You can export that to CSV as well and send it to the call center people. They can target the customer based on their requirement. So that is how you can create the table. And finally, I have to create what? I have to create a visualization. I want to see how my cluster looks like. I have spending score and salary. Based on that, I want to create a plot. So plt.scatter bracket, I want to create a scatter plot because I have two numbers. So when we have two numbers, we usually use scatter plot. X, Y, K means is equal to 0, comma 0, comma X, Y, K means equal to 0, comma 1. I'll talk about it in some time. S is equal to 100, C is equal to red. Now you see that I have something coming up. X, 0 means column number 1. What is my column number 1? Salary. X, 1 means column number 2, which is spending score. So I have salary and spending score. For what? Cluster number 1. So I'm filtering the cluster number 1 data and plotting cluster number 1 data only. S equal to 100 means the size of the circles is equal to 100, and C equal to red means color as red. So this is only first cluster. I have to do the same thing for rest of the clusters as well. So here I will change the value 1, 2, 3, 4. Here also 1, 2, 3, 4. And I want to change the color as well because I cannot have red because I want to segregate the cluster. So let's say pink, yellow, black, blue. And here you go. I have clusters ready with all the different colors. These are my customers with high salary, low spending score, low salary, low spending score, average salary, average spending score, then low salary, high spending score, high salary, high spending score. I have 5 customers. Let's say I come up with a new product which is very expensive. So which students I will target or which customers I will target? High salary and high spending score. So that is how you can create a cluster, and this is the clustering example. With that, we actually created a good 5 clusters, and I can decide which one the cluster I can go for marketing my product based on the requirement. Now, roadmap for becoming data scientist, right? So you can see here, these are some of the job descriptions. Skills required for data scientists, you can see statistics is very much required. Then Python programming is good because Python is very much in demand. So we can go for Python. There are other tools as well like SAS and R, but Python is in demand, multi-purpose language. People are using that. We can go for that for sure. Data extraction, transformation, loading, all you are going into data world, right? So you should aware of all these basics concept as well. ETL, data extraction, load and transform. Data wrangling, exploration. Data visualization is important. Machine learning algorithms, a lot of algorithms are there. We should aware of those algorithms as well. These are some of the takeaways from, you can see, job description from Cognizant. All right, guys, thanks and all the best. Take care.